Download this code from codegive.com, link in the description below. How to check if the X server is running on Linux, a comprehensive guide. The X Windows system, often referred to as X or X11, is the foundation of graphical user interfaces, GUIs, on many Unix-like operating systems, including most Linux distributions. Knowing how to check if the X server is running is crucial for troubleshooting display issues, managing graphical applications, and automating system tasks. This tutorial will cover several methods to determine the X server's status, ranging from simple command line tools to more sophisticated scripting techniques. We'll also explore relevant environment variables and common scenarios where this knowledge proves valuable. Let's get started. Understanding the X server and its role. Before diving into the how-to, it's important to grasp what the X server is and does. Think of the X server as a gatekeeper and traffic controller for all graphical output on your system. It handles the following key functions. Abstraction provides a consistent interface between applications and the underlying display hardware, example graphics card, monitor. Applications don't need to know the specifics of your hardware. Input handling manages input devices like the keyboard and mouse, forwarding events to the appropriate application window. Window management coordinates the display of windows, allowing them to be resized, moved, and stacked on the screen. Network transparency allows graphical applications to run on one machine and display on another, though this is less common today due to security concerns. The X server itself is a process, usually named Korg or just X, that listens for connections from X clients, graphical applications. If the X server isn't running, you won't see a graphical desktop environment like GNOME, KDE, XFCE, or LXDE. You'll likely be stuck in a text-based console. Methods to check if the X server is running. Here are several techniques, from simplest to more complex, to check the X server's status. 1. PS command with grep ***. The PS command lists processes currently running on the system. We can use grep to filter the output and look for the X server process. *PSF* displays a full process list, including user, process ID, PPID, CPU usage, start time, terminal time, and command. The E option shows every process, and the F option provides a full listing. *grep korg filters the output of PSF to only show lines containing the string korg. Korg is the most common name for the X server process. If your system uses a different X server, less common, adjust the search string accordingly. Interpreting the output X server is running if the command returns a line similar to this. This indicates that an X server process named Korg is running. The numbers 1234, 1233, etc., are the process ID, PID, and parent process ID, PPID. The arguments passed to the Korg process, like 0, seat 0, etc., define its configuration. X server is not running if the command returns nothing or only the grep command itself. This means no X server process matching Korg is found. The only line returned is grep itself because grep also contains the string Korg. Example ***. In this example, the X server, Korg, is running with PID 1234. The second line is the grep command itself, which we can ignore for determining the X server's status. To avoid showing the grep process, you can use grep vgrep. This filters out any lines containing the word grep, leaving only the Korg process, if running. 2. grep command ****. Grep is a command specifically designed to find processes by name or other attributes. It's often a cleaner and more concise alternative to psgrep. Interpreting the output ***. X server is running ***. The command will print the process ID, PID, of the X server process if it's running. For example, **X server is not running ***. The command will produce no output if the X server isn't running. 3. PIDOF command ***. Similar to pgrep, PIDOF finds the process ID, s, of running programs by their name. Interpreting the output ***. X server is running ***. The command will print the PID, s, of the X server process if it's running. For example, **X server is not running ***. The command will produce no output if the X server isn't running. 4. Checking the display environment variable ***. The display environment variable tells X clients, graphical applications, where to connect to the X server. If this variable is set, it strongly suggests that an X server is running, or at least was started recently. However, the mere presence of the variable doesn't guarantee that the server is still alive and listening. Interpreting the output ***. X server is running, likely if the command returns a value, such as 0, 0.0, localhost 10.0, or similar, then the display variable is set. This usually implies that an X server is configured and likely running. **X server is not running, or not configured if the command returns nothing or an empty line, the display variable is not set. This often, but not always, indicates that the X server is not running or not properly configured for the current user. Important considerations about display ***. Local versus remote ***. A display value like 0 or 0.0 typically refers to the local display, the monitor connected directly to the machine. A display value like hostname 0.0 indicates that the application is intended to connect to an X server running on a different machine, hostname. *SSH-X11 forwarding * when connecting to a remote machine via SSH with X11 forwarding enabled, SSH-X or SSH-Y, the display variable will be set to a value that allows applications on the remote machine to display their windows on your local machine. 5. Checking for the X server socket file ***. The X server typically creates a Unix domain socket file in /tmp, or /var/run in some systems. This socket file is used for communication between X clients and the X server. Checking for the existence of this file can provide a strong indication of the X server's status. Explanation ***. ***tmp/.x11 Unix. This is the standard directory where X server socket files are stored. **X0 represents the display number. 0 is the most common display number for the primary display. If you have multiple X servers running, you might see X1, X2, etc. Interpreting the output ***. X server is running, likely if the command returns file information, such as. This indicates that the socket file exists, suggesting that an X server is running and listening on that socket. The S at the beginning of the permissions string indicates that it's a socket file. **X server is not running** if the command returns no such file or directory or a similar error, it means the socket file doesn't exist, and the X server is likely not running, or not using the standard socket path. 6. Using sit ***. The sit command is a utility for configuring X server settings. It can also be used to indirectly check if the X server is running. If SIT can successfully connect to the X server, it's a good sign that the server is active. Interpreting the output asterisk. Asterisk X server is running asterisk if the command executes successfully and prints a detailed report of X server settings, like keyboard repeat rate, screensaver parameters, etc., then the X server is running. Asterisk X server is not running asterisk if the command fails and produces an error message such as can't open display or unable to connect to X server, then the X server is likely not running or is inaccessible. 7. Using systemd, for systems using systemd as init system. Systemd is a widely used system and service manager. If your system uses systemd, you can check the status of the X server, or display manager service, using systemd. First, identify the relevant service name. Common display manager services are *GDM, GNOME Display Manager, used with GNOME. *KDM, KDE Display Manager, used with KDE 4, older. *SDDM, Simple Desktop Display Manager, used with KDE Plasma 5 and some other environments. *LITEM, Light Display Manager, used with XFCE, LXDE, and others. *LXDM, LXDE Display Manager, specific to LXDE, older. Then, use systemd status to check the service. Interpreting the output asterisk. The output will show the service's status, active, inactive, failed, etc., its PID, and recent log messages. If the service is active, running, it means the display manager, and, by extension, the X server, is likely running. If the service is inactive or failed, there's a problem. Example output asterisk. In this example, sddm.service is active, running, indicating that the display manager, and the X server it manages, is working correctly. Creating a shell script to check X server status. Here's a shell script that combines several of the methods described above to provide a comprehensive check of the X server's status. This script can be easily modified to suit your specific needs. Explanation of the script asterisk. 1. /bin/bash asterisk shebang line, specifying the interpreter, bash. 2 is _process_running, function asterisk a reusable function to check if a process with a given name is running using pgrep. It redirects output and errors to /dev/null to avoid cluttering the terminal. It returns the exit code of pgrep, which is 0 if the process is found and non-zero if not. 3. Check for korg process asterisk uses is _process_running, to look for korg. If found, prints the PID. 4. Check display variable asterisk checks if the display environment variable is set, not empty, and prints its value. 5. Check xsocket file asterisk checks if the xsocket file, /tmp/.x11 unix/x0, exists. 6. sitq test asterisk executes sitq and checks its exit code. A successful execution suggests that the X server is responsive. 7. Systemd check, if applicable checks if the systemd command exists, meaning the system is likely using systemd. Then, it iterates through a list of common display manager services, GDM, SDDM, LITEM, LXDM, KDM, and uses systemd is active to check if each service is running. If any of these services are running, the script prints a message and exits successfully, exit code 0. If none of the common display managers is active, it prints a message indicating such. 8. Exit code asterisk the script returns an exit code of 0 if any indication of the X server running is found, korg process, display variable set, xsocket file exists, sit is successful, or a display manager is active. It returns an exit code of 1 if all checks fail, indicating that the X server is likely not running or is inaccessible. How to use the script asterisk. 1. Save the script asterisk. Save the code to a file, for example, check_x_server.sh. 2. Make it executable asterisk mod plus x check_x_server.sh. 3. Run the script asterisk dot slash check_x_server.sh. The script will then print a report of the X server's status based on the various checks. Customizing the script asterisk. Adjust process name asterisk. If your system uses a different name for the X server process, other than Korg, change the search string in the is_process_running function and the xorg_pid assignment. Add more display managers asterisk. If you use a display manager not included in the scripts list, GDM, SDDM, LightM, LXDM, KDM, add it to the for loop in the system check section. Customize output modify the messages printed by the script to better suit your needs. Use in automation you can use the script in other scripts or automation tasks to conditionally execute commands or perform actions based on the X server's status. Common scenarios and troubleshooting. Here are some common scenarios where checking the X server's status is helpful, along with some troubleshooting tips. Graphical applications failing to start. If a graphical application fails to start with an error message like can't open display or unable to connect to X server, it often indicates that the X server isn't running or that the display variable is not set correctly. Solution. Verify that the X server is running using the methods described above. Check the value of the display variable. If you're connecting remotely via SSH, ensure that X11 forwarding is enabled, SSHX or SSHY. Booting to a text console. If your system boots to a text console instead of a graphical desktop, it could mean that the X server or display manager is not starting automatically. Solution. Check the status of the display manager service using systemctl. If it's inactive or failed, try to start it manually, sudo systemctl start sddm, replace sddm with your display manager. If the service fails to start, examine the system logs, journal_exe, for error messages. Ensure that your system is configured to boot into graphical mode, usually controlled by the system target or run level. Remote access issues. When connecting to a remote machine and trying to run graphical applications with X11 forwarding, you might encounter issues if the X server isn't running on the remote machine or if X11 forwarding is not configured correctly. Solution. Verify that the X server is running on the remote machine. Ensure that X11 forwarding is enabled in your SSH client, using the X or Y option. Check the X11 forwarding option in the remote machine's sshd_config file, it should be set to yes. Make sure that the zoth command is installed on both the local and remote machines. Troubleshooting display problems. If you're experiencing graphical glitches, screen tearing, or other display problems, checking the X server's status can help narrow down the cause. Solution. Ensure the X server is running and correctly configured. Check the X server logs, usually located in /var/log/korg.0.log or similar, for error messages or warnings. Update your graphics drivers. Security considerations. While X11 was originally designed with network transparency in mind, it is inherently insecure when used over a network. Data is unencrypted, and anyone with access to the X server can potentially eavesdrop on your keyboard and mouse input or inject malicious commands. For remote graphical applications, consider using alternatives like VNC, RDP, or a web-based remote desktop solution, which typically offer better security. Always use SSH-X11 forwarding with encryption for transferring X connections across untrusted networks. Conclusion: knowing how to check if the X server is running is a fundamental skill for Linux system administrators and users. By using the methods described in this tutorial, you can quickly diagnose display issues, troubleshoot application failures, and automate tasks related to the graphical environment. The provided shell script offers a convenient way to combine these checks into a single, customizable tool. Remember to consider security implications when using X11 over a network and explore alternative solutions for remote graphical access when appropriate. Good luck.